We are approaching a post-antibiotic era, a time when common infections could once again kill. Antimicrobial resistance, or AMR, is now one of the world's top public health threats. In the US alone, superbugs cause over 2 million infections and at least 23,000 deaths every year. These are bacteria with the ability to escape our best drugs: Enterococcus faecium, Staphylococcus aureus, Klebsiella pneumoniae, Acinetobacter baumannii, Pseudomonas aeruginosa, and Enterobacter species. For thousands of years, humans fought infections with plants and fungi. Then came a revolution, 350 to 550 AD. Nubians brewed beer containing tetracycline, 1909. Paul Ehrlich developed salvarsan, the first synthetic antimicrobial, 1928. Alexander Fleming discovered penicillin, 1940s. Mass production of penicillin begins. Selman Waksman discovers streptomycin. Antibiotics are precision weapons. Each targets a specific vulnerability in bacterial cells. Cell wall synthesis. Weakened by penicillin, vancomycin. Plasma membrane. Breached by polymyxins, protein synthesis. Halted by tetracyclines, macrolides, nucleic acid synthesis. Disrupted by fluoroquinolones, metabolic pathways. Blocked by sulfonamides. Meet Marisa. She's 52 and she's just returned from Vietnam with severe abdominal pain and fever. She had recent medical care there, including catheterization. Lab tests confirm a urinary tract infection. She's prescribed ciprofloxacin, a common antibiotic. Resistance isn't just biology. It's fueled by our actions in three key ways. 1. Patient noncompliance. Stopping antibiotics early when you feel better but aren't cured leaves the toughest bacteria alive. They multiply, creating a resistant infection. 2. Clinical misuse. Prescribing antibiotics for viral illnesses like colds or flu. It's ineffective treatment that trains bacteria for nothing. 3. Agricultural overuse. Routine use in healthy animals for growth and disease prevention creates massive reservoirs of resistance. Each action selects for superbugs. Changing these habits is our first line of defense. What bacteria fight back? They've evolved sophisticated defenses, drug inactivation, enzymes like V-lactamases destroy the drug, efflux pumps, eject antibiotics from the cell, target mimicry, decoy proteins trap the drug, target modification, bacterial structures change so drugs can't bind. Marisa isn't getting better. The ciprofloxacin isn't working. Lab results reveal why. She's infected with a strain of Klebsiella pneumonia that produces New Delhi metallobeta-lactamase, an enzyme that disables even our strongest antibiotics. She has a CRE infection, a carbapenem-resistant superbug. To defeat a resistant infection, we must find its weakness. Using tests like Kirby-Bauer disk diffusion, scientists measure the zone of inhibition and determine the minimal inhibitory concentration, the lowest dose needed to stop bacterial growth. Marisa's susceptibility testing shows her infection is resistant to almost everything, except tigecycline and polymyxins. She switched to intravenous tigecycline. It works, she recovers. Her case shows why we need rapid diagnostics and last resort antibiotics. But here's the problem. New antibiotic discovery has slowed dramatically. Why? The economic model is broken. Antibiotics aren't as profitable as drugs for chronic conditions. As a result, Big Pharma has largely abandoned antibiotic R&D. Hope isn't lost. New strategies are emerging, tapping untapped environments like soil and oceans using tools like the iChip, smarter synthesis, combinatorial chemistry to create thousands of drug candidates, disarming the enemy, developing inhibitors that block resistance enzymes. Winning this arms race requires more than new drugs. It requires a smarter strategy. Clinicians, prescribe wisely, use diagnostics. Patients, take antibiotics as directed, never for viral infections. Policy and industry, fund research, create incentives, regulate agricultural use. The battle against superbugs is a defining challenge of our time. We must commit to stewardship, using existing drugs wisely, surveillance, tracking resistance globally, science, innovating relentlessly. The future of medicine depends on how we act today. Join the fight. Learn more. Scan to visit the World Health Organization's page on antimicrobial resistance. If you learned something new in this battle, hit like, subscribe, and ring that bell for more deep dives into the science shaping our future. Let me know in the comments. What questions do you have about superbugs?